So it is my pleasure to introduce the last speaker of or the last competitor of our second heat, Jason No Pressure. Jason Rebello, who is a PhD student in Professor Wasslander's group. Jason is going to be talking about enhancing the vision of autonomous robots. All right, I think there might be a pun in there. So, okay, Jason, whenever you're ready, the next 3 minutes, all yours. Take it away.
Have you ever wondered how we sense the world around us? Every waking moment, our senses flood us with sights, sounds, smells, tastes, and touch. For example, imagine eating this delicious chocolate cake without being able to see it or without being able to taste the sweetness. While each sense has its own strength, when working in isolation, they have their limitations. So the way to guarantee a truly enriching experience is when all of our senses work together in harmony. Now, senses are to the human body what sensors are to machines. This harmony is particularly crucial with the vast number of self-driving cars hitting our streets all across the world. In order for these autonomous vehicles to function safely, we equip them with a variety of sensors such as LiDARs, cameras, GPS, and radars. Look at the figure on the left. What appears as a mixture of points, lines, and colors to us is precisely the information received by the self-driving car from each of its sensors. In order for this vehicle to function intelligently and have a holistic view of the environment, we need to be able to relate the information from each of these sensors into a common frame of reference. In other words, we need to know how these sensors are positioned or calibrated with regard to each other. Now, this itself is a challenging problem. However, there's a fundamental concern that arises, is that the sensors on these systems are fixed with regard to each other. One such sensor that provides the richest source of information for us is the cameras. In the current fixed configuration, the robot might find itself in situations where one or more of these cameras has its vision occluded due to certain aspects that can severely affect the safety of our systems. We as human beings, on the other hand, have our ability to move our head and our eyes around, focusing on the most informative areas of the environment. So why aren't we giving robots the ability to do the same? That is exactly where my research comes in. During my PhD, I have been working with dynamic camera clusters, which are systems that can reconfigure the cameras on the fly and direct cameras to point to the most informative areas in order to extract that information needed for achieving a particular task. I've been applying principles of information theory, which are ways to quantify the information so that we can relate these measurements accurately and have these sensors and cameras work in harmony. If we do not equip our drones and our autonomous vehicles with the ability to actively seek out this information and relate it, I don't know if we can trust them with our lives. Therefore, calibrated dynamic camera clusters are essential for robots to perform reliably and guarantee our safety. Thank you.